We're going to do hyperbolas today. So 8-3A. 8-3A. All right. We're only doing half of the lesson.
Yes.
Yeah, I don't want to overwhelm you this weekend with information. So today we're going to be given an equation. We're going to find all the pieces. And then on Monday we'll be given some pieces, and then you have to find the equation. So let's go over the equation of a hyperbola. Do you know what a hyperbola looks like? It kind of looks like two parabolas, right, in a way? But they actually go out straighter than a parabola does. A parabola curves really nicely like that, and then a hyperbola is kind of go out like straight. All right, so here you're going to have two forms. So here they are. Here's the first one. We're going to have x minus h squared over a squared. And so far, it looks exactly like an equation for an ellipse. But then we changed it from a plus to a minus. And when you subtract it, it changes the graph a lot. So y minus k squared over b squared equals 1. I always think of an ellipse as plus because I'm taking the two parts and I'm adding them together and bringing them together as a whole unit. And then hyperbola is minus. I'm taking that ellipse and I'm subtracting it out so it goes away into two parts. Okay? So this is a hyperbola, and it's all about which variable comes first. Okay? So if it's x minus y as opposed to y minus x, that makes a really big difference. So here, because x is first, this hyperbola, what you would do to graph it is you would go to its center. So it has a center of hk. And I don't know if you remember how to do these, but you would go a distance of a left and right. Those are your vertices. Okay, your vertices would then be at h plus or minus a comma k. And then what you do is you draw a rectangle. You would go a distance of b up and down, so that would be b. And you draw a rectangle here that is going to help you to draw the ellipse, hyperbola, sorry. All right, so this right here, this distance is A, and this distance here is B, okay? And then you draw that rectangle in order to get the asymptotes, which go straight through the corners of the rectangle and the center of the hyperbola. And then finally, you draw the graph. Like all of that, the only thing I have on the graph so far is just those 2 points. The graph now will go like this, and you go right along the asymptotes. So the black part that I drew here, out of all these colors, the black part is really the only part of the graph that is the actual graph of it. Everything else is just there to help you graph it correctly. Okay? So there it is. That's a hyperbola. Now, there are foci. The foci are going to be inside the bowl. So your foci now go past your vertices. And the foci, the length of that is still c. Okay? And then the equation for the foci would be c squared equals a squared plus b squared. Bless you. An ellipse, it was minus, but a hyperbola, it's plus. So if your equation of your conic section has a minus in the equation, then the foci will have a plus and vice versa. If there's a plus in the ellipse, the minus would be in the foci.
What's the foci?
Yes, and so then the foci, the foci are a distance of c away. So the foci are these green dots here and here. They're inside of the bowl, so they're past the vertices. And the foci, their coordinates would then be h plus or minus c comma k. Okay? And then one more thing. They are going to ask you for the asymptote equations. Okay? Asymptote equations. So they want to find out what the equation of that line is and the equation of that line. Now, you don't have to find the equation of a line by finding 2 points on the line and doing that whole thing. The asymptote equation looks like this. It's pretty easy. It's just point slope form in kind of a different way. So you have a point on the line, which is the center. So you're going to do this. Y minus k equals plus or minus rise over run. But do you see what the rise is here? What is that? B. And what's the run? A. So it's just plus or minus rise over run, or B over A, times x minus h. It's really just point slope form. Y minus y equals m, x minus x, right? Do you remember point slope form, or has it been too long? Point slope form is y minus y1 equals m, x minus x1. And that's what this is. Yeah?
Is that a plus or minus?
Plus or minus, yeah. Because you have two equations, two lines. So one's going to have a positive slope, and the other one has the negative slope. Rise over run.
Wait, so is it just to the B or is it to the A and B?
Well, if it's to the A and B, then it'll just cancel each other out. So it's like out in front.
B over A?
Yeah, like you can, here, if you don't like that. It could either go with the top or the bottom, but not both. So I would probably, you could just write it out front, plus or minus, like that. Okay. And then, of course, there are the hyperbolas that go up and down. All right. So, oh, no, don't write that, don't write that. So the equation of those would be y minus h, no, dang it, I'm off my game this week. Y minus k squared plus x minus h squared. That's a minus in the middle. Wow. I mean, at least I'm catching my mistakes, but I'm just making too many.
Do you want to
Just take a, I was going to call in sick today. I was going to take like a personal day. I'm allowed to do that. There's days that I can just take off, but I have to do it ahead of time. Kind of like your college visits. I was going to do that today, but you know what? It's faculty luncheon day, and I'm not about to miss a free meal. So that's why I'm here. Yeah. Plus, you guys, I'm teaching ham. The rest of the classes won't. Okay.
Why don't you just leave after lunch?
Like just ditch my last 3 classes?
Yeah.
That would have been pretty cool.
Just don't even show up.
Yeah, but then I got to come back because my kids take the bus and they're here at 3. So it's like,
Have them walk home. You live
ooh,
close.
I don't. Not that close. All right. So let's say that that's the center. And these are the things that are going to change. You're going to go up and down a distance of b. And those are going to be your vertices now. Okay? So those are now points on your graph because they went first. Not because B or A is bigger. That's ellipses. Don't get them mixed up. They're different, okay? It's because Y comes first. So then your vertices would then be, so center is at HK. And be careful because so many people are just used to just going here and there. You know what I mean? Like this one and then that one. But it's H and then K. It's always whatever's with the X and the Y. People switch that all the time on accident. I probably would today. All right, so then if you go out a distance of A this way and A that way, then you can draw your rectangle again. Everything's all pretty much the same. And then you draw your asymptotes. And then finally your graph. And your graph will go up and down instead of left and right because Y went first this time. Okay? Everything else stays pretty much the same. So the vertices are now going to be on the Y part of your center. So it'd be H and then K plus or minus B. The foci are going to be, in the bowl part. So now they're a distance of C from the center now. So the foci would be at H, K plus or minus C. And then foci equation is always A squared plus B squared equals C squared. And the asymptotes are the same too. That didn't change at all. So just remember foci equation, asymptote equation, and then graph the rest of it. Okay? Yay! Shall we do one? Let's do 2. Let's do one of each. Do we have time? What time are we out? We're like really early today.
Why? Good one.
Because it's senior lunch. 9 o'clock, we're out. 10 minutes early. I heard that. Number 1. Okay, let's see. Let's do this one. Maybe you only need one. I don't know. Let's do this one. 9y squared minus 16x squared minus 18y minus 32x minus 151 equals 0. Okay. Yeah. Are you guys getting this a little bit better this year?
Kind of, sort of.
Yeah?
It's so way too many formulas.
It's a lot of formulas, I
I
know.
feel like last year we had a lot more proofs.
Proofs. Oh, really?
Like he showed us like, why
Huh.
does this work this way?
Oh, yeah, yeah.
Get it.
Yeah, with the foci and stuff. I should, but we just don't have time. Okay. So let's go ahead and we can tell this is a hyperbola because we have 2 squared terms and there's a minus between them.
Is that 150?
Yeah, that 151. All right, so now what we're going to do is we'll get our y's together and we'll factor out a 9. So y squared minus 2y plus blank. And then for the x's, you need to factor out a negative 16. So negative 16 factors out, and you're left with x squared plus 2x plus blank equals 151. Okay? All right, now here is going to be one little different thing that you've never done before. Every time you've completed the square, you've always added that number to both sides. Okay? You're actually going to subtract a number to both sides. So we're going to take half of negative 2 is negative 1, and we're going to square that. And that's going to be 1. And then we're going to do 9 times 1. We're going to add 9 to this side. When you go over here and you take half of 2, which is 1, and you square it, you're actually adding negative 16 to this side. So we want to subtract 16. Okay? That's really the only difference. Everything else is pretty much the
Didn't
same.
we already did that once,
When?
right? Didn't we? Isn't
No.
this just completing the square twice?
Yeah, but the difference is that you're subtracting a number. We've always added a number to both sides. So right there, this is a negative 16 times 1, so you have to subtract 16. Okay, so you get 9y minus 1 squared, negative 16x plus 1 squared equals 144. Okay, and then go ahead and divide everybody by 144. Make sure you show, all this work in your homework this weekend. 144, and so then you get y minus 1 squared over 16 minus x plus 1 squared over 9 equals 1. So beautiful the way they make these work. Okay, so that would be to, as the book would call it, prove that that's a hyperbola. Okay, I would say write in standard form for hyperbola. That's the way I would word it. All right, now we need to find all the things. We're going to find the center, the vertices, the foci, and the asymptotes. And we're also going to graph this whole thing. Okay, it's going to be a lot. It's like a big problem. And if you mess up here in the first parts where you're completing the square, none of these answers are going to be right. So you're going to get like minus 10. No, I'm just kidding. I would probably look at your work and see where you went wrong.
100% right, and we just made like an adding error. How many did we take
Yes,
off?
like just tiny bits, really. Like
Like
all
half.
10. Yep, 0. That
Nick,
sucks.
Nick, you're like people out in the back.
I know. All right, so what's the center? The center is,
Negative 1.
yes, you were careful. See how the x is first over here, or the h goes with the x and the k goes with the y. So it's going to be negative 1, positive 1. That's where people will make a mistake. They just do. Okay, so we'll go over here to negative 1, positive 1, and that's the center of our graph. Okay, so because y is first, not because of b squared is bigger than a squared, but because it's first, we're going to go up and down a distance of 4. So 1, 2, 3, 4. That's one of my vertices, and then 1, 2, 3, 4. I really didn't spread these out very well. Okay, and I'm okay. If you want to write your vertices as negative 1, 1 plus or minus 4, I'm perfectly fine with that. Okay? If you don't like that and you'd rather write 1, 5, or negative 1, 5, and negative 1, negative 4, or that's 3, right? Negative 3, then you can do that too. But I just think that's an easy way to write it. Okay, and then I would want to draw the rectangle. I'm going to look for that. You have to draw that. So we're going to go out 1, 2, 3 in each direction. Draw a rectangle here. It goes through your vertices, because this tells you the shape of it. It tells you how wide your hyperbola is going to be. The asymptotes, those are pretty good.
Hey, how'd you know how far out to go?
So 3. So that 9 right there, yeah, you go a distance of, so this would be, I'll draw it this way. This would be A to there, and then up and down is B. And then you can draw your graph finally. 7 minutes. There we go. And there you go. Nice, huh? Aren't those pretty? They're so fun. Okay, the foci. The foci are located out here, distance of C from your center out to there. And so the foci would be at C squared equals A squared plus B squared. Oh, this is a nice one, huh? This is really nice. It worked out way too perfect. It's gross. All right, so you get plus or minus 5. You get 25, and then you take the plus and minus square root, and you get C equals plus or minus 5. So you can, if you want to, write your foci. Your foci are from the center, and they're going up and down from the center. So the center was -1, and then you can just write plus or minus 5. If you want to, you can actually find that that point is -1, 6, and this point is -1, -4.
Do we ever, do you have to find the vertices out there?
Those aren't vertices.
Or not?
Nope. So vertices are on the graph, and those points aren't on the graph at all. The only part of this graph is just this black part here and this here. So those aren't considered vertices. But you need them to draw the rectangle, though. Okay, and then the asymptotes. Last part. Asymptotes. All right. The asymptotes, what you're going to do is you're going to put this into point slope form. The point you're going to use is the center. Everything comes from the center, okay? So the center point is -1, 1, and we're going to put this into point slope form. So you're going to do y minus 1 equals plus or minus rise over run. If you, yes, b over a. B in this case is 4, and a is 3. So plus or minus 4/3, and then x plus 1. Point slope form. It's been a while. I mean, I think it's like chapter 2 or 1 or something since we did point slope form.
It's all good.
You good? Okay, do you feel like you need a